In with Sarah Allan. The next host of this show will drop by to share an article by our colleague Jason Davis about the water on Mars. Want to work for the Planetary Society? Sarah will also tell you about a couple of job searches underway. Bruce Betts will tell us when and where to enjoy the total lunar eclipse that is days away as this episode becomes available. The interstellar dust does not spell out surrender Dorothy, but the green cloud otherwise looks like it could be the work of a wicked witch, and that's why it tops the Halloween edition of our free weekly newsletter, The Downlink. Down below is the Hubble Space Telescope's image of asteroid Dimorphos with dual trailing tails. You'll hear it mentioned in my conversation with Lindley Johnson and Kelly Fast. Think it's hot outside? Probably not as hot as an exoplanet dubbed GJ1252b. How hot? Gold and silver would melt into pools on its surface. That's based on data from the Spitzer Space Telescope. As always, there's much more in store at planetary.org/downlink. Sarah Allan has another couple of months as our digital community manager. Sarah, welcome back. Of course, it's our intent that you be heard regularly on these programs, leading up to when you take over with the first Planetary Radio episode of 2023. You must be excited. Looking forward to that.
Oh, I am. And it's so exciting to begin my training on this job already. I've had such a great time.
I hope that continues. I hope you're able to say that you enjoyed this transition period once you reach January 4th. In the meantime, we've got other stuff to talk about, starting with an article by our terrific colleague, Jason Davis. What a great writer. On October 25, he posted this piece called Your Guide to Water on Mars, which is as good a brief guide to where we're going to find H2O on the red planet as anything that I have read.
People want to hope that there used to be life on Mars in the past. We know that this planet used to have oceans of liquid water, but something changed at some point. So getting an overview of what was the situation in the past, what is it like now, and how we can use that water going forward with our science exploration is very useful. But it's just not the planet it used to be, and that's a little sad for me. How do you feel about that, Matt, that like Mars used to be a place covered in water, and now it's just a dusty rock?
I love those animations that simulate what Mars may have looked like billions and billions of years ago. They're generally done with careful scientific accuracy, so they don't show stuff growing all over the place. They just show all that water. Maybe someday we'll terraform it. But in the meantime, as Jason has written about, there's still quite a bit of water hiding away up there.
There is, and it's really useful to know how we can get at that for a few reasons. We want to find life, or maybe where life used to exist on Mars. So water as we know it for life is useful, but we can also use that water for things like creating fuel, or if we're going to send humans there, create human habitats, we might want that water for them to drink, to create plants, or maybe if we're going to get really fancy with it, we can use that water and some Martian dirt to 3D print some habitats or something. That would be really exciting. Most of the water on Mars is locked up in water ice caps at the poles. Trying to get at that water at the poles is a little difficult because it's easier for us to send space missions to Mars somewhere near the equator. We need that cushion of atmosphere to really kind of slow down our spacecraft when they're incoming. So we try to head around that area. Finding water in other places outside of those poles is also very useful. Rovers on the surface have been looking at hydrated minerals that were formed on Mars in water. And if we can crunch those up, we can get to water there as well. But an easier way to actually get at the water on Mars is probably in ice under the surface. The surface is covered in this dusty layer, but when the Phoenix lander was on Mars back in 2008, it actually just a little bit under the surface found water ice sitting there waiting to be harvested. And
if you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program.
It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention the darn good friends of York University. I'll be one of your hosts tonight. It's a party of three, a threesome. Julie, hi there.
Hi.
And we've got Satish.
Hello.
Party of three, as I said, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada, where it is snowing piteously. Oh, I'll get to that in a minute. This is Astronomy Night in Canada. How typical. Where the lineup is entirely Canadian, starting with ourselves, York Universe, on to Western Worlds, Quirks and Quarks, Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, which is Tuesday morning, 2 a.m. Universal Coordinated Time at this time of the year. Yes, we ditched daylight saving time. The York Universe production works in concert with our online public viewing program, handled, of course, by the ever-ready Observatory team. Hi, Ilham, Anita, not to mention Sana. It runs, not surprisingly, between the hours of 9 and 10 p.m. local Toronto time. Coincides with our show, in other words. Please, by all means, point your favorite web browser to observatory.info.yorku.ca. Join the chat room. As I said, it is snowing, so there will not be any live new images tonight. But, of course, we have a wonderful stack of past images, and the chat room there will be filled with content from us as well as the team. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. If you've got any questions or comments you have about our past shows, all 395 of them, or if you have suggestions for future topics, particularly the next 5, please, by all means, send an email to observe@yorku.ca. Follow us on Twitter @YorkUniverse. We will be, of course, monitoring the chat room. If you've got questions and the team gets stumped, they can't answer it, we will try. By all means, post content there because that's what we will be doing. So, definitely a blast of winter there, folks, today.
Tell me about it.
Well, at least the GO trains were on schedule.
Sure. I may also have misnavigated a corner and wound up hopping a curb on my way home this evening.
Okay. You and the car in that order are okay, I'm assuming?
Everything's fine. Nothing is ruined.
Right, just a little embarrassed.
Yeah.
Yeah, okay. Did you tell Dennis?
Well, he is not home.
Oh, so we have kept it from Dennis. Okay, so everybody out there, no telling Dennis.
No, he'll know when he gets home. I'll tell him.
Oh, dear. Okay. What about you, Satish? Are you enjoying the snow?
That's a good way to rub it in. I actually, Googled if carrying an umbrella in this snowstorm or whatever this thing is would be a good idea. So I got, of course, loads of opinions coming up from people, and then there were articles about Vancouver and people using umbrellas in snow, and then it's not liked by people, and that was like weird. But it's not about whether it is effective or not, but it's not liked by people sometimes. So anyway, I decided I wouldn't carry it. Yeah.
Okay, so let's ask Julie, the only true Canadian of the threesome here. Have you used an umbrella in a snowstorm?
No, I have not.
And the answer is in front of you there, Satish. Put the umbrella away.
But I would not judge. I would not judge if someone was using one, because I did see some people use them today.
Yes, actually, so did I. I must admit, so did I. And I thought, gosh.
Kind of makes sense.
Yeah, kinda.
It's water ultimately, right? So, and umbrellas are made for water.
Well, this is true. It's just a different state of water. Yes. That's quite correct. Anyway, folks, if you haven't quite gathered, Toronto has had an unusually early dump, around about 10 centimetres in the local GTA. It certainly does not bring the city to a standstill, but it does all make us shake our heads and go, oh gosh, is this going to be a long winter? ? We'll have to see. We'll have to see.
It made
All right.
for one last word on it. It did make for pretty Remembrance Day celebrations.
That's true. No question in the world about that. On this day, it certainly did add a artistic touch to the whole affair. And snow in general does add for a picturesque appearance. If you didn't have to shovel it and you didn't have to drive in it, it'd be absolutely perfect. But unfortunately, most of us have to do one or both of the aforementioned. Anyway, the way must be tried, as York University would say. This week in space and astronomy history, let me lead, folks. Okay, Apollo 12 launched on November 14th, 1969. Needless to say, this was the second landing on the moon, following, of course, the quintessential Armstrong and Aldrin gig in July of 1969. The three on-board astronauts, Conrad, Gordon, and Bean, Pete Conrad and Allan Bean, were the two moonwalkers. They took Intrepid down to the lunar surface, leaving poor Gordon in the Yankee Clipper that was orbiting around the moon at that point in time. Unlike the Apollo 11 mission, this was aimed to be what is often referred to as a precision landing. You might recall when we've chatted about Apollo 11, or you've seen the various movies out there, Armstrong had to wrestle control of Eagle from the onboard computer, that tremendously powerful PDP whatever, and basically flew the Eagle to a safe landing. Not what they call precision landing. By the same token, any landing you walk away from is a good one, and as I say, Eagle landed safely. But this time round, and for future lunar missions, they wanted to be able to land more or less exactly where they wanted to improve the science yield. And so the charge to Conrad and Bean was put this guy down near the Surveyor 3 spacecraft. Surveyor 3 was one of the soft landing missions, April 20th, 1967, in the Sea of Storms, Oceanus Procellarum. So the plan was put it down there. Well, they more or less did so. They were within sort of a couple hundred meters of exactly where they wanted to. Conrad, who was flying it in, more or less said, yeah, not quite where I want to go, and sort of steered a little bit away, but close enough, within 200 meters of the landing, and easy hiking distance to the Surveyor 3. So by all accounts, it was a precision landing. Now, unlike Apollo 11, these guys had a color camera with them. The Apollo 11 mission was monochrome, and everybody who has ever seen Armstrong and Aldrin bounding around the lunar surface, it was in black and white. Well, they upgraded to a color camera for Apollo 12. Problem is that Allan Bean, despite the fact that he is an artist and did wonderful artistry back on Earth for 30, 40 years after the Apollo 12 landing, despite his familiarity with cameras, he managed to point his terrifically expensive camera straight at the sun as he was setting it up, and basically blew out its internal electronics. As a consequence, we got almost zero imagery from the Apollo 12 mission, which was really sad, despite the fact that it had a much better camera. Anyway, there were a few still images floating around the place. C'est la vie. These things happen. They did 2 EVAs, one over to the Surveyor 3 spacecraft, picked up all sorts of good stuff there, deployed the Apollo lunar sampling and exploration package, the ALSEP package, basically had a really good time wandering around the moon's surface, and even picked up pieces from the Surveyor 3, which are on display actually at the Smithsonian Air and Space Museum. Amongst other things, they picked up the lens from Surveyor 3, which did wonderful imagery in and around its landing site back in '67. Now, interestingly enough, there was a controversy, and in fact, it's probably never going to be resolved. There was believed to be, for many years, indeed many decades, an onboard bacteria inside the camera lens that they brought back from the moon. Not too good at pronunciations here as far as long syllable medical terms, but Streptococcus, I think is the way it's pronounced, mitis.
It is.
Oh, thank you. Okay. Was brought back from the moon, or at least it was purported to have been brought back from the moon. And for many, many years, that was the belief. So, in other words, the camera wasn't fully sterilized before it was launched to the moon. I mean, the moon's a pretty sterile place, so nobody was too concerned about that. And it appeared to survive for the 2.5 years on the lunar surface. And then the astronauts brought it back. And it was one of the big stories through the 70s. However, a controversy has raged ever since because the actual examination of the lens, the camera lens, looks as if the examination violated clean room protocols. And so there is now a wide body of belief that suggests that the contamination on the lens actually occurred back here on Earth, not carried to the moon, survived for 2.5 years, and brought back. There have been at least 3 independent reviews launched by NASA to try and get to the bottom of it, the most recent one being 2011. So as this story has had legs, it really has. My reading of it is that nobody is really sure, is the bottom line to it. There is no doubt that there were violations of clean room protocols while handling this lens. That's pretty clear. Whether or not that accounts for the contamination of the lens is really up for debate. And as I say, we'll probably never figure it out. At any rate, it's one of the wonderful stories associated with Apollo 12. They landed back on November 24th, splashed down in the Pacific, picked up by the USS Hornet. And Allan Bean himself, both Bean and Conrad, unfortunately have passed away. But Allan Bean was immortalized, shall we say, by the recent Cygnus cargo carrier launch to the International Space Station because it bears his name. The Allan Bean is currently docked with the International Space Station. So, as I say, Apollo 12 launched November 14th, 1969. Second lunar landing, astronauts 3 and 4 to walk upon the surface of the moon.
I must
Why
say.
can't they just... Sorry.
Continue. Go ahead, Satish.
I was just saying, why can't they accept the fact that it was whatever, the bacteria, basically.
Contamination.
The contamination, yes.
It's not so much that they don't want to accept it, it's just that it casts doubt on the whole affair. I mean, if you've got people who are not handling the camera in a sterile way, apparently the people who are handling it they had bare arms, so as to speak. They were wearing gloves, mitts, but beyond that, the rest of them was exposed. Does tend to suggest that contamination was a possibility. The bag that they brought back the camera in was not an airtight bag, so of course it was breathing air from the Earth the moment they touched down. So it's not so much that they don't want to accept it, but it casts doubt on whether or not the bacteria did in fact survive the 2.5 years of extreme environmental exposure on the moon. A lot of people would like to say, bacteria are really that resilient, but other people are saying, give me a break, can't happen that way.
Well, it could be one or the other, but we'll never know from this particular instance. A really good story to share with students in lab class.
Yes, exactly. Follow protocol or your results are tainted. That's really the bottom line to it.
Well, you should not forget to talk about grades being affected.
Cutting to the chase, are we here, Satish? Cutting to the chase.
Absolutely. So.
Yeah. Anyway, it's an interesting side story. I mean, Apollo 12 was a very successful mission. They got struck by lightning during ascent, but the Saturn V was a bit of a beast in that regard. It just shook it off and carried on. It was a great second mission when all was said and done. Yankee, Clipper, and Intrepid, and the 3 astronauts, to the moon and back. So, whichever way you want to put it, it was a good sequel to Apollo 11. Take us a little further out here, Satish.
Absolutely. So I will talk about the Philae lander. I wish I could play on the word a little more, but I can't. So Philae was a lander which was launched with the Rosetta mission, and it touched down on a comet known as Churyumov-Gerasimenko.
Churyumov-Gerasimenko. Yep.
Okay, that was a good one. Okay. So it is or it was a robotic lander from the European Space Agency that accompanied the spacecraft. And the space probe was launched on the 2nd of March 2004. November 12th, 2004, that's like after almost 10 years, the lander landed on a comet, like the comet which we're talking about, and it bounced off the surface at a velocity within close range of the comet's escape velocity. It then transmitted scientific data for, I think, less than 2 days, and then before its batteries died and the lander went into safe mode, it was recovered later, probably a year later, but the story about this date is that that's when it landed on the surface of the comet.
It was a successful landing. Ultimately, it just ended up being a little bit like Skippy the kangaroo. It sort of bounced across the surface.
Mm-hmm.
I think it bounced 3 times, 2 or 3 times. I can't quite remember.
3, yes.
3 times, okay. And that was a little unfortunate. They knew that the gravitational field associated with the comet CG was light, and therefore Philae would have to do some pretty extraordinary things to stay put. Unfortunately, all their precautions went for naught. They had a pressurized cold nitrogen bottle on the top of the lander, which was supposed to activate the moment Philae touched the surface, and the nitrogen gas was supposed to keep the spacecraft on the ground. Didn't work. They had harpoons ready to go, so you can imagine, everybody going, okay, we're touching down, launch the harpoons, and they were supposed to stick into the surface of Comet CG. That didn't work either. So as a consequence, we ended up with this bouncy, bouncy, bouncy problem, and that meant that Philae ended up nowhere near where they had originally intended. And as you indicate, Shadish, they didn't actually know where it ended up. It transmitted for nearly 3 days, actually. I think it was about 68 hours all told before the onboard battery failed because the solar panels couldn't see the sun. They were basically ending up at the foot of a little cliff in deep shadow. And that, of course, spelt the demise of Philae. But the science return was always designed around a 72-hour battery lifetime. So to all practical intents and purposes, something like 90% or more of the lander's mission priorities were achieved. It's just everybody gets so used to having a spacecraft that lives forever that everybody hoped that we would get much, much more data, but they just got the bare minimum.
And it was 90 minutes for 12 hours day on the comet that the equipment was receiving sunlight.
Yeah,
it had to.
Yeah. I mean, if it had stuck its landing, it was in the middle of an open plain, and the solar panels would have been just fine. And if it had only bounced once, it would have been fine. But unfortunately, as I said, harpoons and the nitrogen gas bottle both failed, and the spacecraft just couldn't stay put out in the open. It was really sad.
Well, yeah, bad job. All right.
Well, what made it particularly sad were all the little anthropogenic drawings of Philae and Rosetta being like, "Where are you, little buddy?"
Yeah. What's the term? Anthropomorphize. We all.
Did I say the anthropogenic? I meant anthropomorphized.
Oh, okay. Well, no, there could have been another verb in there that I just didn't recognize. English is my third language. I mean, Australian, Canadian.
Anthropomorphized.
It is still English, right?
It's still English, yes. But the Rosetta mission was really, I think a very key moment for ESA. They launched it, as you indicated, Shadish, in 2004. So it was fully 9+ years of deep space coasting before Rosetta was woken up, went into orbit, performed brilliantly while in orbit around the comet, swept in past perihelion and back out again. I mean, whichever way you want to cut it, it was really great. And then its final swan song, so as to speak, was Rosetta touching down on the comet. So that, it was great. I remember the broadcast from the European Space Agency while they were tracking the signal, basically the tone that said, yeah, I'm still here, I'm still here, I'm still here. And then when it touched down on the surface, the onboard programming said, I'm going to stop transmitting. And it did. And the hush across the ESA control room, and the Capcom there, ceremonially took off his headset and put it down and walked away from the console. I mean, it was great drama. It really was. Back, many years ago now. Oh, anyway. Okay. So much for Philly. Thank you very much. Moving back to the planet Mars for a moment. November 13th, 1971. That was the moment that the Mariner 9 spacecraft went into orbit around Mars. Now, up until that point in time, many spacecraft, primarily NASA spacecraft, had ventured past Mars, particularly Mariners 6 and 7. These were flyby missions, Mariner 4 as well. The plan was to sort of check the place out, so to speak, and see what there was on the planetary surface, look for, growing vegetation, and so on. And so after the three previous flybys, which had revealed a much more cratered surface than we had anticipated, and a dichotomy between the southern hemisphere and the northern hemisphere and so on, Mariner 9 was destined to go into orbit in 1971 so that we could stay up close and personal for at least a year, surveying the planetary surface. All went very well. This was one of the primary missions that Carl Sagan was associated with. But the moment we went into orbit, there was this huge dust storm raging on the surface of Mars. Now, dust storms on Mars, of course, are not particularly unusual. They are sort of, decadal, every 10-year events. You can have a lot of smaller ones that happen quite frequently, but about every 10 years, literally the entire planet gets swallowed by a global dust storm. Cue the loss of opportunity 2 years ago. At any rate, this one was a global dust storm in 1971, and so we'd spent all these years waiting for Mariner 9 to get into orbit, and got into orbit, looked down, and all we could see was swirling dust in the upper atmosphere. Couldn't see a darn thing. So we all waited patiently, and then the volcanoes, Olympus Mons and the Tharsis Bulge of volcanoes, all began to poke out above the settling dust. And we knew that we really had a spectacular mission on our hands. Shortly thereafter, as the dust settled even further, we began to see the glimpses of Valles Marineris, the big Rift Valley that cuts across the center of Mars. So it was well worth the wait, but I'll tell you what, it was very frustrating for the first couple of months. Mariner 9 operated for well over a year, dazzling us with their imagery. It was their up-close and personal images that really suggested that there was once flowing water on the surface of Mars. Not by today's standards, but by then, the high-resolution imagery showing the carved nature, which really looked like river deltas, the areas that resembled inland seas, the signs of past water activity, erosion, and so on the surface of Mars were really quite unmistakable. And this was all courtesy of the Mariner 9. We take it for granted now that when we launch a spacecraft, it's going to go into orbit around Mars. And the European Space Agency, the Indian Scientific Research Council have all done it. And just trying to think, yes, the Russian Federation has also managed to put spacecraft in orbit around Mars, although not for very long periods of time. But back in 1971, nobody had done it, and Mariner 9 was the first. So hats off to Mariner 9, launched November 13th, 1971. And of course, neither of you were around to see that live. Oh.
No, definitely not.
I remember it very well, needless to say. It was the exciting culmination. The 70s showed so much promise. We've been to the moon. It looked as if anything was possible. Of course, we now know that the lunar program was about to be canceled. But the Mariner spacecraft, Pioneer, it's 10 and 11, Voyagers 1 and 2, they were all on the books. and as was Viking. So it was the beginning of a decade of great promise as far as planetary exploration was concerned. So it was a good way to start the whole process there in 1971 with Mariner 9.
What's the problem with the dust storm?
Can't see through it. That's the short answer.
Okay.
I mean, when you have a planetary-wide dust storm and it swirls material into the upper atmosphere and you can see no surface detail, then you go rats, or slightly stronger commentary.
That's probably a nightmare for planetary scientists, right?
Oh, absolutely. Can you imagine how upset John Moores would be to wait for 10 years or whatever to finally get the spacecraft in orbit, the spacecraft of your dreams, in orbit above the planet, ready to reveal secrets that nobody has seen before, and all you can see is dust? Yeah, I think I'd be pretty ticked.
Yeah, it's similar to this snowstorm that happens today, and we missed the Mercury transit. So.
Yeah, that's true. We'll be talking a little bit about that shortly. That sums it up very well indeed.
All the scopes are ready, and snow.
That's exactly right. We picked a really good day to try and do a Mercury transit. Carry on, Julie. Take us back to 1974.
All right. Okay, so it's November 16th, 1974, and Arecibo launches the first official interstellar SETI message into space. The message was designed by Frank Drake and Carl Sagan, two pretty well-known names. And it was sent to M13, which, if I'm not mistaken, is a globular cluster.
Yep.
In the Hercules constellation. And that cluster is about 25,000 light years away. It was part of ceremonies after some major upgrades to the telescope. 210 bytes of data lasting 3 minutes at 2,390 megahertz. It was really more of a display of the tech than a real attempt to contact extraterrestrials. The message is arguably decipherable.
Have you seen that photograph? I mean, really? You've got to
have.
What?
I have. I have. It's neat. And, but
human.
But apparently it's been given to some, pretty smart people to try to decipher, and they were like, yeah, no, I have no idea what this is.
Yeah, that's my point.
Yeah. If you have a legend of what everything is, it's like, oh, yeah. So the information includes the numbers from 1 to 10 in binary, the atomic numbers of hydrogen, carbon, nitrogen, oxygen, and phosphorus, because they make up DNA, the formulae for sugars and bases in nucleotides of DNA, the number of nucleotides in DNA based in 1974 data, and a graphic of a double helix, because DNA. Graphic figure of a human with the height for average man and the human population of Earth back in 1974.
Now, what useless information is that? I mean, really? I'm sorry. Go.
It was, I know, right? Like, useful in 1974.
Yeah, on that particular day.
Yeah. Graphic of the solar system indicating which planet the message was coming from. Okay, kind of useful. Still valid. And yes. A graphic of the Arecibo telescope itself with the dimensions of the dish. And this all based in binary, ones and zeros.
Was it a song? There was a song as well, right? Or am I talking about different message?
No, there wasn't a song on this one. You're thinking of the messages from planet Earth that are on the Voyager records, I think.
Okay.
Yeah. That's okay. It's the same person, Carl Sagan.
Yeah.
Yes. Yeah. Okay. Yeah.
I mean, I don't want to belittle the effort. I'm all for having sent it, and you've got to start somewhere in trying to transmit a message out to the universe. But I tell you what, if anybody can decipher that it's very impressive. It really will be. That's for sure. But as I say, trying to figure out what to say and how to say it is a non-trivial exercise. So
yeah, I'm going to put a link to an image of it in the chat. That may or may not have worked. I don't know. Someone tell me. It looks like it did. All right.
I mean, as I say, you've got to start somewhere, and that's as good a place as any. But you really have to wonder how successful that type of a message is. And then, as you say, 25,000 light years away into the Hercules, that means, of course, traveling at the speed of light, it's going to be a 25,000 year one-way trek. If somebody picks it up and transmits back, that's a 50,000 year round trip travel time for the conversation. Yeah. Okay. I think I probably would have launched it a little closer. But maybe that was part of the point, that the transmission was not intended to be necessarily received by somebody quickly. And I now think of all of the science fiction shows out there that talk about alien invasion. 25,000 years from now, probably we've improved our tech to defend ourselves. Maybe that was part of the logic. I don't know.
If we're even still around, come on.
Yes, that's, I know I won't be. That's for sure. Anyway, Carl Sagan, Frank Drake, and so on, both from Cornell University at that era in time, and our first serious message out to the stars. Satish, bring us back a little closer in time, please.
Absolutely. Hey, wait a minute. Okay, so
I mean, closer than 50,000 years of round-trip travel time. That's what I was referring to.
Yeah. Oh, okay. I mean, I usually don't get jokes because there is a part of my gray matter which has died. So sorry about that.
So sad.
Well, actually, it is sad, but nobody believes me. So, anyways, I had to still clear my quantum and other assignments or whatever.
Carry on.
Yeah, I got. Sorry, guys. So, Skylab 4, November 16, 1973. That's what we're talking about. That's when it was launched. This was the third crewed Skylab mission and placed the third and final crew aboard the first American space station, which was the Skylab. A Saturn IB rocket was used to launch the mission from the Kennedy Space Center, and the mission lasted a little over 84 days. Amongst a lot of other things that space missions do, which I'm not talking about, it was part of a controversy over photographing the Area 51 and whether they should be released, and then they were released with other photographs, and then people didn't even notice for a long time that Area 51 had been photographed. So happy birthday, Skylab.
Interesting. I hadn't actually realized that was the mission which Area 51 had been imaged. Yeah.
I love it. Love it.
Yeah. Do you remember, by the way, talking about Area 51, the Facebook party back in September over there at Area 51?
Wasn't that where everyone was going to invade Area 51 or something?
Yeah, that's it. Apparently, up to a couple of thousand people did descend on the local towns there. It was a big boon for the pubs and the hotels, and they had some music contests and so on. But I think only 2 people, and that was a good thing, tried to cross the boundary line, which the Air Force more or less said, "Thou shalt not pass." And 2 people did try. I think they were arrested, and that was that, not shot. But Area 51 has mystique and pizzazz, shall we say.
Yeah.
But the Skylab 4 mission, 84 days. Now, again, we take that for granted these days with the International Space Station, but 84 days was a huge length of time back then. The 3 Skylab missions, Skylabs 2, 3, and 4, were basically 28, 56, and 84, nice multiples of 28, days in length. And as you can see, they were systematically working their way to longer and longer time periods to see how well the human body was going to adapt in space. And the third and final mission, 84 days, everybody came back happy as all get out. It was also the 3 missions which more or less set the tone for future activities in space, the long duration missions of the shuttle and now the International Space Station, the 3 Skylab missions are credited with working out the protocols that would basically say, I'm not working 7 days in a row in space and then starting all over again. That is to say, there was definitely decommissioning time, personal time where the astronauts could do anything except what NASA wanted them to do, and so on. And the protocols for those types of activities were worked out during the Skylab missions, during these long durations. So when you think
about memory serves, it was because the crew turned off comms for a day.
They went on strike. Quite correct.
Okay.
Yeah, well, basically NASA was working the astronauts 7 days a week, and some of those days were really long. And the astronauts basically at some point said, enough of this. We are not going to work 24 hours a day, 7 days a week. We're going to take some time off. So as Julie quietly points out, they sort of went on strike and turned everything off and took the day off. And after that, NASA and the astronauts sort of sorted things out, and they come to a more equitable division of life and labor, and that has carried through to the types of schedules that were on board the space shuttle as well as the International Space Station. So, it goes back to the Skylab missions.
Do they have an astronaut union now?
No, they have an astronaut office, which more or less says, okay, this is going to be the way it is. So there's a negotiation, if you will, between the astronaut office and, I guess, NASA management. Yeah.
It's funny.
Julie, finish us off, please.
Okay. It's a birthday shout-out, because we must have birthday shout-outs. Friedrich Wilhelm Herschel was born the 15th of November, 1738. Sidebar, he was around till the 25th of August, 1822. He's from a famous astronomical family. His sister was Caroline Herschel. After immigrating to Great Britain, he built his first telescope in 1774 and proceeded to map the sky for the next 9 years. He found Uranus on the 13th of March, 1781, and is famed for many observations, including the Martian polar ice caps, seasonal variations, the discovery of Titania and Oberon, which are moons of Uranus, and Enceladus,
Yeah.
Thank you, and Mimas, the moons of Saturn.
Yeah, Mimas, of course, is the Death Star, right? It's
Yes.
a big cover-up, right?
That's no moon.
Says Han Solo. Yeah. Shadish, have you seen Star Wars?
I have, but I never remember the names of the characters. And like Han Solo, I think is he a Skywalker?
No. Han Solo is the rogue,
No, he's
the
Solo.
dashing rogue who he's Han Solo, who sweeps Leia Organa off her feet and marries her, and so on and so forth. Anyway, that's a whole other story. Okay, yeah. Herschel, the Herschel family, lots and lots of astronomical heritage there. The son of William Herschel was John Herschel, carried on the family tradition, so as to speak. It really was an astronomical organization. It really was. And famed in particular for the planet Uranus' discovery. Although, of course, there are many purported observations of Uranus from centuries gone by, all the way back, in fact, to perhaps even Galileo. But those folks didn't figure out what it was. They sort of noted it in logs, but carried on. So they didn't have the optics to resolve it into a disk, and they didn't follow it to realize that it was moving. But Herschel, being the sky mapper that he was, paid attention to such little details. And so he is credited with finding Uranus. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory here at York University in Toronto, Ontario, Canada. Julie, Shatish, myself, Paul, waxing eloquently this week in space and astronomy history. And lots of interesting stuff there. By all means, point your favorite web browser to observatory.info.yorku.edu Join the chat room. Black Projects is there. Eric is there, along with many members of the Observatory team, chatting about bits and pieces and sharing wonderful imagery in the chat room area. Couple of quick shout-outs, or reminders perhaps more to the point. For those of you who weren't up this morning, SpaceX managed a few firsts. They had their launch of their second Starlink collection of satellites. So they launched 60 satellites into orbit today. But perhaps the bigger point was that they launched those 60 satellites from a Falcon 9 first-stage rocket booster that had flown 3 previous times. So this was the 4th flight of this booster, and its 4th landing that it stuck on the drone ship, Of Course I Still Love You, and it's on its way back to Cape Canaveral. So up and back 4 times, and they even flew or reflew a shroud. So it was a pretty big day for SpaceX today. So tip of the hat to Elon Musk and his team. They are really putting the RE in reusable as far as space hardware is concerned. Also, the ISS, the International Space Station, at the moment does not have funding secured beyond 2024. And that is only about 4 years and change away. Hard to believe. It's been continuously occupied for, well, close enough, 20 years now, but we're within 4 years of the funding envelope being basically ripped up and thrown away. They are now seriously beginning to talk about extensions to 2030. This is NASA. NASA and the Russian Space Federation are the two principal key players, financially speaking. It is a consortium of 16 nations, but you'll certainly need to have at least one, if not both, the Russian Space Federation and NASA on board to extend to 2030, regardless of what the other sort of 14 nations would want. Well, they're now talking about it. So I was very, very pleased to see that. Stay tuned, because there's obviously lots more ground to cover. The last item that I wanted to pass on, the 2020 Allan Carswell Observatory calendar is in production. Yay, drum roll.
Yay!
Yay, yay. They will be available next week. So for those folks who would be interested in getting a copy of our 2020 calendar, resplendent with many images from the 1-meter telescope, take a bow, Sunna, they will be available next week. Drop us a line at observe@yourq.ca. We'll then package one up and send it off to you. And like the previous 5 years, inflation still hasn't struck this universe calendar. It's still only $10 Canadian. So if you're at all interested, drop us a line.
Sign me up.
Absolutely. One set aside for you. Not a problem. Okay, we've got 3 news items that we want to pass on to you folks. And I'll lead the first one. Yes, we mentioned it earlier, but today was meant to be the transit of Mercury. Well, it did happen despite the snow here in Toronto, which was really, really annoying for those of us who wanted to see it. But the Mercury transit did take place. Local time here, 7:30 in the morning, Eastern time, through to just after 1 o'clock. So about, give or take, 5 hours worth of transiting activity. As I said, we were unable to see it here in southern Ontario. We were completely blinded by the snow. Didn't stop NASA transmitting wonderful imagery from the Solar Dynamic Observatory. Really neat, actually, watching the transit in a number of different wave bands. So it went ahead, of course. That's what celestial mechanics will do for you. It doesn't wait for snowstorms to clear. It just went ahead and did it. And Mercury glided across the solar disk. Now, it might be a bit of a surprise to folks, but we actually didn't know that Mercury did this sort of thing until the early part of the 17th century. Kepler's laws and then Galileo and so on and so forth. They all began to figure it out in the early part of the 17th century. And it was Gassendi who actually observed the first Mercury transit in 1631. So we've not been doing this for very long, about 400 years, give or take. Perhaps the most important scientific result that comes out of transits, either of the Mercury transits or the Venus transits, because both of them do this sort of thing, is the accurate determination of the distance to the sun. Up until that point in time, we had no definitive measurements of the Earth-Sun distance. We knew the relative distances of Mercury, Venus, Earth, and so on from the Sun, assuming the heliocentric model was correct, which it is, but those relative values required an absolute measure, and the absolute measure, the Earth-Sun distance, was not evident to anybody until people sort of said, aha, we can use transits. We can make observations of Mercury or Venus with respect to the background star, aka the Sun, and if you make simultaneous observations from different parts of the Earth, parallax will enter into the conversation, or the geometry, more to the point. And by using that geometry, the parallax geometry, knowing the separation of your observing stations on the surface of the Earth, knowing the angular movement associated with Mercury from those base stations, you can then, with simple geometry, determine the distance to the Sun. And that's what they started doing in the 18th century, not with Gassendi in 1631, but with Venusian transits during the 18th century. This was all figured out by Edmund Halley. So there was really good science afoot as far as the transits are concerned. Not so much of importance today. Of course, monitoring where Mercury ends up moving across the solar disk does help us reaffirm the orbital parameters of Mercury. But perhaps the biggest science that gets done with transits today is the sunlight, the starlight, passing through the atmosphere of a transiting planet, Mercury or Venus. And of course, we here on Earth doing spectroscopy can actually make measurements of the light passing through the atmosphere. Now, everybody there in the chat room, I'm sure, is jumping up and down and going, Mercury doesn't have an atmosphere. Well, in fact, you're absolutely right. It doesn't have an atmosphere, but it does have an exosphere. There is a very, 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 did I say very, thin, tenuous atmosphere that hugs the Mercurian surface. And then when you're passing sunlight through that atmosphere from our perspective, you can do spectroscopy and make measurements of the composition of the exosphere, the density of the exosphere, the population density of the individual elements in that exosphere, and so on. So there still is science for these types of transits. Anyway, Mercury was doing its thing today. It only does it about sort of 13 to 15 times a century. So do the arithmetic, that means sort of like, roughly speaking, every 7 years or so. Today's transit is the last until 2032. Sigh. Okay, I'm not going to be on the York campus making that observation with my students in 2032. I do hope to be observing it, but not from York. But unfortunately, the 2032 transit is not visible from North America. So those folks who are waiting for it in North America, I think it's like 2039 before the next one comes around. So yeah, we blew it today with the snowstorm here in southern Ontario, but nonetheless, transits of Mercury, transits of Venus still hold a place near and dear to the hearts of many astronomers. They're the choreography of our solar system in action. You can be observing it crisply and cleanly with appropriately solar filtered telescopes. No squinting at the sun here, people. But it really is still a very neat observation to make. Unfortunately, we did not see it live today from Toronto.
Next time, Gadget.
Next time, Gadget. That's right. Yeah, it's a real shame, but c'est la vie. These things do happen.
It is.
Yeah. Okay, move us on there. A little bit of history, I believe, is coming our way, Julie.
Sure. All right. So those who listen regularly know that when I can, I like to bring in stories that bring my day job into things. A part of my day job is talking about fossils. So there is a hypothesis called the Younger Dryas Impact Hypothesis. And it states that the extinction of the Ice Age mammals may have been triggered, at least partially, by an extraterrestrial object colliding with Earth about 12,800 years ago. So this hypothesis was first proposed in 2007 and proposes that an asteroid or comet crashed into Earth, causing a period of cooling that contributed to the extinction of 35 species of megafauna, including saber-toothed cats, mastodons, and mammoth, all those really cool animals. This would also coincide, this period of time, also coincides with the decline in early human population, for example, the Clovis culture in North America. So if there was an impact, it would have caused massive wildfires, and all of that soot and stuff in the atmosphere would have blocked sunlight, causing an impact winter near the end of the Pleistocene epoch. So there is a group of researchers headed by Christopher Moore, and he is from the University of South Carolina. He's an archaeologist, and his team has found evidence of impact at a site called White Pond, which is near Elgin, South Carolina. And this study isn't the only one of its kind. It's actually building on previous research. They're looking for platinum spikes, so unusually high levels of platinum in the soil, which is associated with cosmic objects. There have been other sites that have the similar type of data have been found all over the world. South America, Africa, Asia, and so the evidence is mounting to support this hypothesis. Another team has found high concentrations of platinum and iridium in sediments in a recently discovered crater in Greenland. This could have been an impact point, though it hasn't been precisely dated yet, but the possibility is good that it could be like the smoking gun, quote unquote, that people are looking for to confirm that it would have been a cosmic event. So there's other evidence as well. There is, hold on, looking for my thing, my words. There it is. There's been melt glass discovered and microscopic spherical particles and nanodiamonds that would indicate enough heat and pressure was present to fuse materials on the Earth's surface. The presence of iridium is associated with cosmic objects. And these are similar things that were found in the rock layers that were dated to 66 million years ago, when a more different impact contributed to the dinosaurs' extinction. So stay tuned as more and more data pile up. We may go from this is controversial to, yeah, this is what happened.
Certainly when we look back through the geologic record, there is many extinction level events that have taken place. And I think it's fair to say that the prevailing theory is that each of them has been associated with an extraterrestrial origin. But, because it is, so far back in time, we're talking about tens of millions, hundreds of millions for many of them. The evidence can be, shall I say, challenging or at least disputable. But as you say, Julie, the evidence is mounting. The more we look into extinction level events, there seems to be just more and more evidence on the side of extraterrestrial activity. And we're not talking aliens here.
No, just rocks.
Yeah, rocks, which of course suggests that we're in a very dangerous part of the solar system.
Yeah.
Yeah.
Kind of is what it is. Not much we can do about it.
No, there isn't. It would be good if we could get a little more funding to sort of, figure out possible deterrents, gravitational tugs and, more telescopes looking for those objects that are going to smack us hard and hurt us and so on and so forth. But it's really been a challenge over the years to mount sufficient funding to put a dent, shall I use that term, in the problem. So hopefully, as we produce this type of evidence, signifying that there is more and more extraterrestrial danger around us, that politicians and administrators will, release the necessary funds. Fingers crossed. Fingers crossed. The iridium layer, though, is not just the only way for us to suggest that it's extraterrestrial, shall we say, for the disappearance of the dinosaurs. Satish, we have one more news item before the top of the hour. Take it away, my friend.
I'm sure, sir. This is a heavy one. So, our home, the universe that we live in, it's actually round, according to some new, research. So, as far as theoretical astrophysics is concerned, we've been made to believe that the universe is as flat as anything flat can be. And there is this lambda CDM model, which is also called the standard model of the universe, which establishes this using 6 parameters to explain the flatness of space-time. But, if it's not challenged, it's not true physics. And researchers from Sapienza University of Rome seem to have unearthed some observations from the Planck satellite's last data release that seems to lean towards a round or a closed universe. Although one of the authors of the paper published in Nature has expressed clearly that the point is not as much about the closed structure being true as it is that if the data were interpreted with a closed universe model, the existing theory will have to be seriously investigated. Now, it has been known for a while that the Planck satellite data, show that there is warping happening in the universe of the cosmic microwave background, and that's more than what's predicted by the standard model. There is skepticism, though, that the current interpretation might be due to a statistical fluctuation, and on the other hand, there is approval from some that the observations could simply be better explained by a closed universe model. Now, some heavyweights, Dan Hopper, from the Fermi National Accelerator Lab, said the research or the evidence is not compelling enough. It's not of the high standard that would convince him of the proposition of a change in the existing theory. René Hlozak of the Dunlop Institute of Astronomy and Astrophysics also mentions that we maybe do not understand the systematics properly, and there could be a systematic error in the statistics, which the physicists need to be sure whether issues could simply arise from those issues. So, just to refresh our memory on the cosmology of it all, in an open universe, parallel lines will always move further apart. In the closed one, it will eventually meet. And for the flat guy, they never meet. So it should be mentioned that none of these have to deal with the fact that the universe as a whole is expanding. Cosmic expansion means that points in space are spreading apart over time, and the shape of the universe deals with the shape of space. So a spherical balloon can expand as it is inflated, just as a flat rubber sheet can be stretched and remain flat. So our expanding universe could be flat, open, or closed. Now, since the curvature of space is affected by the presence of mass, the overall shape of the universe depends upon the average density of matter within it. And in general relativity, this value is given by the density parameter, which is the ratio of the observed density to the critical density needed for the universe to be flat. So based on all this, there's also a controversy called the Hubble tension, wherein experiments measuring the cosmic microwave background cannot seem to agree with experiments measuring closer objects when it comes to how fast the universe is expanding. And the authors mentioned that the consequences of assuming a flat universe when the universe is actually round could be dire.
Bottom line to it is we still haven't quite figured out what the universe really looks like.
It could be dire. That's hilarious.
I'm quoting this from the article, seriously.
I'm sure it is, but it's unlikely that we're going to roll the clock back. And anyway, folks, we're at the top of the hour. You've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory. Satish, Julie, and myself, Paul, have been keeping you happy tonight. We'll see you again next week.
Good night.
You may find more of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm radio.
AFM.